We begin this problem by first drawing a free body diagram. In this case, we have a cantilever beam which is loaded at end B by an 8 kilogram weight. This beam is built into the wall and so supports reaction forces in the X and Y direction. It also supports a moment because it's built into the wall. We complete our free body diagram by adding the dimensions. Now, we calculate the weight using the acceleration of gravity. This gives us a weight of 78.5 newtons. Now we sum the forces in the x direction and find that the reaction force at A in the x direction is 0. The moments about A are given as counterclockwise positive, and we consider the force acting at the end as well as the built-in moment at the built-in end A, arriving at 125.6 newton meters. Now we sum the forces in the y direction, which includes the 78.5 newton weight pointing downward and the positively directed reaction force in the y direction at A, giving us 78.5 newtons acting upward at A. The second problem loads the beam a bit differently. In this case, we have a 0.1 meter diameter pulley fixed at end B. This is loaded again by the 78.5 newton force vertically downward, but we must also consider a force horizontally directed to the left of 78.5 newtons. We now add the reaction forces at the built-in end, which includes the x and y directed forces, as well at the moment at the built-in end. If we sum the forces in the x direction, we now find that the x component of the force is 78.5 newtons. The y component, as before, is going to be 78.5 newtons again. We now take the sum of the moments about the built-in end A, and we have to consider the moment generated by both of those tension forces. We assign clockwise positive, we add the built-in moment, the moment directed vertically downward. The point is that we have to get the moment arms correctly labeled. The vertically downward directed force 1.6 plus 0.1 meters. The other one pointing to the left is 0.1 meters. The sum of those moments give us the reaction moment of 125.6 newton meters. The third part of the problem, we load the beam differently again. We again hang a weight off the end of the pulley, but we tether that weight to the ground, which generates two 78.5 newton vertically downward forces. We again add the reaction forces at the left end, making certain to include the moment, and we label the length of the beam. We then calculate the sum of the forces in the x direction and again find AX is equal to 0. The y-directed forces tell us that AY is twice the force of the weight hanging off the end of the beam. We then take the moment about end A and find, assigning direction counterclockwise positive, we have the moment at A and we have the moment generated by each of the vertically directed downward forces at the end of the beam B, taking account of the 0.1 meter diameter radius of the pulley. This then gives us a moment about A of twice 78.5 newton meters, giving us 251.2 newton meters.